Hello everyone, this is me Professor Punesh Tembhare from Department of Computer Technology. In this session, we will introduce regarding the subject design and analysis of algorithms. Very first, we have to understand about the importance of this particular subject. That's why we have to go for why this particular subject is included into our syllabus. Basically, whenever we want to solve any particular problem with the help of a computer, the basic steps are very first we have to go for the designing of algorithm, and then from that we have to go for the program. So ultimately program is the final solution for our problem. So that's why ultimate solution will be the program. But how does this program will be derived? So that for any particular problem we can directly write down a program, but before writing a program we have to create the blueprint of that particular program, which is generally called as a algorithm. Now, whenever we are going for any algorithm design, this is a completely documentation procedure. Documentation procedure means that here we don't have to go for the implementation. All the things we have to do over the paper and pages only. And that's why whenever we want to do any particular changes, those changes will be carried out within less amount of cost. Second, whenever we have to go for the alternative design, at that time derivation or development of alternative design will be very easy. So therefore whenever we are going for the problem solving with the help of directly programming, it will not be feasible for us. It will be cost effective only when if you are deriving the algorithm, and from that algorithm you are going for the implementation of a program. So if you want to do this, the very first step is that you have to be aware about how the algorithms are developed. This is the first thing. Therefore, you must know about how does algorithm can be designed. Therefore, we have to go for the study of various algorithm design techniques which we have to study under this subject. Second thing, once I have any algorithm, after that I have to check for the efficiency of that particular algorithm, because if I have given any particular problem, for that particular problem, several algorithm will be available, like algorithm 1, algorithm 2, algorithm 3. So these three are the different alternative for solving this particular problem. Now, the question is that among A1, A2 and A3, which particular algorithm is best suitable for me? So for that, I have to go for the analysis of all these algorithms. So how to perform the analysis of all these algorithms, that also we have to study under this subject. That's why name of this particular subject is design and analysis of algorithm, where we have to study about various algorithm design techniques and how to perform analysis of all these algorithms. Next, what are the objectives of this particular subject? So basically there are three objectives. First objective is analyze the time complexity of recursive function. Because most of the time what we are doing, whenever we are designing any particular algorithm, these algorithm will be of recursive type. And at that time, we have to compute the efficiency of that particular algorithm. Now this efficiency will be computed in the form of time complexity. It can be computed in the form of space complexity. So how to compute time complexity and how to compute space complexity? This is one of the important objectives. So specifically under this particular subject, we have to study how to compute the time complexity of various algorithms, and specifically any algorithm will be of recursive type, then how to compute it, that we have to study. This is what our first objective. Then we have second objective, analyze the asymptotic performance of algorithm. Now, whenever we are going for the algorithm analysis, algorithm can be analyzed in the form of time complexity as well as space complexity. But asymptotically, if we want to compute the complexity of algorithm, here basically three kinds of notations are there. That is big O notation, big omega notation, and the theta notation. So with respect to these kinds of asymptotic notations, how to compute the best case, worst case, and average case complexity of any algorithm, that also we have to study. And the third objective of this particular subject is we have to be aware about what are the various algorithm design techniques, which are generally called as the design paradigms, and how to perform the analysis of all these designs algorithms. So these are the basic three objectives. Next, we have to study about the various course outcomes. On successful completion of this particular subject, students will be able to achieve total 5 course outcomes. These outcomes are as follows. First outcome is argue the correctness of algorithms using inductive proofs and analyze the worst case running time of algorithms using asymptotic analysis. So specifically, whenever any algorithm will be available with us, at that time we have to check whether that algorithm is correct or not. And if algorithm is correct, then we have to analyze is worst case, best case, and average case complexity with respect to the asymptotic notation. This is first course outcome. Second course outcome is based upon unit number 2, where we have to go for the study of designing of algorithms by using divide and conquer and greedy algorithm design technique. CO3 is based upon unit number 3, where we have to go for explain and apply dynamic programming algorithm design paradigm. So on successful completion of this particular unit, students will be able to apply the dynamic programming algorithm design technique for any particular problem. CO4 is based upon unit number 4, which is explain and apply black-tacking algorithm design paradigm. And CO5 is about unit 5, which is corresponding to the NP completeness theory, that is describe the classes of P, NP and NP complete and prove the NP completeness for certain problems. So in this way, on successful completion of this course, students will be able to achieve all these 4 kinds of course outcomes, 5 types of course outcomes. Then we have to study about the syllabus of for this particular subject. Entire syllabus is divided into 5 units. Unit 1 is regarding the introduction to the algorithms, finding the complexity and solving the recurrences. So very first, here we have to study about what exactly algorithm is. Second, what are the various properties of algorithm? Then we have to study about the mathematical concept regarding the summation of arithmetic and geometric series. Then we have to go for solving recurrences, because basically whenever we have given any particular algorithm, this algorithm will be of 2 types. Iterative program code will be there, and the second kind of code will be the recursive. So that's why if we want to go for the iterative program code, at that time the algorithm complexity will be computed on the basis of some arithmetic and geometric series. Whereas if recursive function code will be there, then we have to go for solving of recurrences, and therefore for solving of recurrences we have to study the various method like characteristic equation method, recursion tree method, master method, and finally we have to analyze the complexity of algorithm with respect to the asymptotic notations like big O, big omega and theta. And lastly, we have to study about the best case, worst case analysis of insertion sort as an example. So all these are the contents of unit number 1, where we have to study introduction to the algorithms, how to find out the complexity of iterative codes, how to find out the complexity of the recursive program. And final, we have to analyze the best case and worst case complexity of insertion sort. This is unit number 1. Then we have unit number 2. Unit number 2 is mainly divided into 2 parts. And basically unit number 2, unit 3, unit 4, all these units are based upon the various algorithm design techniques. So unit number 2 is specifically dedicated for 2 kinds of algorithm design techniques. These design techniques are divide and conquer strategy and the greedy strategy. So into the first half of unit number 2, we have to focus upon the divide and conquer strategy, where we have to study how to derive the binary search algorithm using divide and conquer, then quicksort, merge sort, Strachan's matrix multiplication. So all these are the various problems which we have to design or we have to solve by using the divide and conquer strategy. Into the second half of unit number 2, we have to go for some of the problem solving by using greedy strategy. So into greedy strategy, very first we have to study about the fractional knapsack problem. Second will be the Hubman code problem. Third, traveling salesman problem. Fourth, activity selection problem. Fifth, job sequencing with deadline problem. Minimum cost spanning tree problem. Here we have to study Prim's algorithm and Kruskal algorithm. Sixth one is about single source shortest path problem. Here we have to go for Dijkstra algorithm. So all these are the units related to all these are the topics related to the unit number 2. Then we have to go for unit number 3. Unit number 3 is about the dynamic programming strategy. And this is what the most important unit, because most of the time any problem can be solved in an optimized way by using the dynamic program. And that's why there will be the consequences that we have to find out the optimal solution for a given problem, and definitely we have to go for the dynamic programming. So therefore here under this unit we have to go for how does dynamic programming can be applied to design the algorithm. So here we have to study about the various problems. These problems are like longest common subsequence problem, which is commonly called as LCS problem. Second, matricial multiplication problem. It is also called as optimal parenthesization problem for matrices. Third, optimal binary search tree, that is the OBST. Then single source shortest path problem. So by using dynamic programming also we can solve the single source shortest path problem. So specifically here we have to focus upon the Bellman-Ford algorithm. The next, traveling salesman problem, all pair shortest path problem. In all pair shortest path problem we have to study the algorithm like Floyd-Warshall algorithm. Then multi-stage graph problem. Into the multi-stage graph problem, we have to study about the both the approaches of solving multi-stage graph problem, like a forward approach and a backward approach. Then 0-1 knapsack problem, which is also called as binary knapsack problem. All these problems we have to solve by using the dynamic programming strategy. This is about the unit number 3. Then we have unit number 4, where we have to study about how to design the algorithm by using the backtracking strategy. Now, backtracking strategy is a strategy which is generally used by the human being. Mostly what we are doing, whenever we are trying to solve any particular problem, at that time we have to apply the trial and error basis. Means very first we have to try, and after trying, if we are not getting the solution into that particular path, then we have to change the path. So such kind of strategy is called as the backtracking strategy. And mostly most of the algorithms are used in artificial intelligence are based upon this backtracking strategy. Therefore, into the today's era, this algorithm designing strategy is also very important. So under this backtracking strategy, what are the topics which we have to study? So very first we have to study about what are the various terminology in backtracking strategy. The very first, various term. Then second, we have to go for the two types of backtracking. What is recursive backtracking and what is iterative backtracking. So that's why recursive backtracking and iterative backtracking we have to study. Third, we have to go for the solving of various problems. So some of the problems are included into this unit, like n-Queen's problem, sum of subset problem, graph coloring problem, and Hamiltonian cycle problem. All these 4 problems we have to solve by using the backtracking strategy. This is about the unit number 4. And at the end, we have last unit, which is unit number 5. This unit is completely dedicated to the theory of NP completeness. And theory of NP completeness, this unit is very important because this is what related to the research. Nowadays, most of the research is going on into this particular topic. Whatever the research scholars are there who are doing their research into the algorithms, they have to follow the theory of NP completeness. So specifically, what are the topics which we have to study under this unit? The topics are like deterministic and non-deterministic algorithm. Because NP completeness theory is directly applicable to the non-deterministic algorithm. Why? Because if ENP word is there, so ENP is corresponding to non-deterministic polynomial time solving problem. That's why NP completeness theory is mainly focused upon the non-deterministic types of algorithm. Therefore, very first we have to the information regarding what algorithms are deterministic and what are non-deterministic. Therefore, this particular topic is we have to study. Then second, decision and optimization problems. Third one is the various classes of problem into the ENP completeness theory. So basically there are P class, ENP hard class, ENP complete class. These different classes of problems are there. So all these classes we have to study. Then next is the polynomial reduction. Mainly the complex problems are reduced into the simpler one. And how to solve this complex problem by reducing into the simpler problem by the theory of NP completeness, that we have to study under the polynomial reduction topic. Finally, we have to go for the clique problem and the Cook's theorem. So these are the topics which we have to study under unit number 5. At the end, we have to discuss about the books. If you are studying this particular subject, you have to follow specifically two books as the textbooks, and these two textbooks are Introduction to Algorithm by Thomas H. Corman. Basically, this is what called as the Bible of algorithms, and the second book is by Elias Horowitz and Sartaj Shahani. Name of the book is Fundamentals of Computer Algorithms. Apart from this, there are two reference books which are included into the syllabus. Books are Design and Analysis of Algorithms by Parag Dave, and the second book is by Computer Algorithms by Sarah Basse and Alan Malgedler. So these are the books regarding this particular subject. This is all about introduction to the design and analysis of algorithm subject. Thank you.